Hey guys, the objective of today's video is to go through an example where we'll determine the bearing capacity for a shallow footing. So here we have a shallow footing which is below the depth of the surface of the soil. And we have different soil conditions on either side of the footing. So on the left side of the footing is at a depth of 0.4 meters below the surface of the soil. And at the top of the soil we have a surcharge of 20 kPa which is applied. On the right of the footing, we can see that the footing lies at a depth of 1 meter below the surface, and there's also a water table which is at a height of 0.4 meters above the base of the footing. Now we're dealing with a long strip footing here with a width of 1.5 meters, and the question is asking us to determine the maximum allowable force per meter run. So this is per unit length because we're dealing with a strip footing, which could be placed on the footing assuming a factor of safety of 3. Now if you note here, we're given two sets of data for the cohesion and angle of friction. So we have an undrained cohesion of 30 kPa and an undrained angle of friction of 0, as well as a drained cohesion of 5 kPa and a drained angle of friction of 25 degrees. So this means that we have to consider both an undrained analysis and a drained analysis. Now in the case of an undrained analysis, the Hansen's equation for the bearing capacity of a footing actually changes to this form. So QU equals to 5.14 multiplied by CU, 1 plus SCU, so that's a shape factor, plus DCU, the depth factor, minus ICU, the inclination factor, minus BCU, the base factor, minus GCU, the ground factor, plus Q0, that's the uniform pressure